Hey guys, welcome to your new unit, new chapter. This chapter is all about polynomials, which sounds like a very intimidating word. It just means many terms, but you'll learn that throughout the lesson. Today we're going to look at adding and subtracting polynomials. In all honesty, like if you can combine like terms, you can add and subtract polynomials. That's all there is to it. Subtraction may be a little bit more involved just because people still tend to struggle with subtracting negative numbers and things along those lines. So first part of this lesson, there's a lot of vocab. If you can, obviously, I suggest that you print out these guided notes. If not, please hit pause in the video a lot to write down the things that you need to write down. So these vocab words, they're not passing. It's not like they just show up in 7.1 and we never see them again. In future lessons, you'll be told how to do things, and the words you're being used to tell in those instructions are going to be the vocab words from this. So they don't go away in this chapter, and they don't go away throughout mathematics. It's going to be really important that we know how to find the degree of monomials, what a monomial is, what a polynomial is, how to classify polynomials, and how to add and subtract them. So like I said, most of this is vocab. The only part of this that wasn't vocab was the adding and subtracting, and that's just combining like terms, something you've seen before. Let's take a look how this works. Okay, pretty wordy. Finding the degree of a monomial. A monomial is a number, a variable, or a number and a variable being multiplied together. That's what the product means. So 5 is a monomial. X is a monomial. 5x is also a monomial. So mono means one. And the meals part is kind of like term. We're talking about one term. 5 is clearly one term. X is clearly one term. 5x, because they are bound by multiplication, mathematically is one term. It is a monomial. So let's just make sure we've got all that, product of one or more variables. And for what it's worth, if I had something like 5x squared y, it can have multiple monomials parts. 5x squared and y would all be monomials on their own. When multiplied together, they still make just one term in their product. Maybe good to contrast that with something that's not a monomial, just so we're clear. 5 plus x. Note, 5 is a monomial, x is a monomial, but if I try to bundle them together with addition, they're not monomials. They're monomials if they're bound together as a product, multiplication, not if they are bound together by addition. All right, next thing we're going to talk about is the degree. So why do we care about degrees? Mainly because if I know the degree of a polynomial, I'm going to know the behavior, and this takes a little bit to something like pre-calc to get, but say you told me I had a 7th degree polynomial. Well, if you told me I had a 7th degree polynomial, I would know that the behavior of the graph would look something like this. It would start way over in the negatives. It would have 1, 2, 3, 4, 5, 6 turns, and eventually go up somewhere in the positives. Now, I couldn't tell you exactly where those points are yet, but when you get to calculus, you actually can figure out all of those turning points. So I know that my graph's going to look something along these lines just because somebody told me it was the 7th degree. So if we're trying to understand the world around us, knowing the degree of a polynomial is very helpful. We can already visualize the behaviors we're trying to describe. So how do we find that degree then? If the degree is something we're going to need in the future, how do we find it? The degree of a monomial is the sum of the exponents of the variables in the monomial. That's a lot to unpack there. The sum of the exponents of the variable. So let's just say I had something like 5x squared y z to the third. Okay, first of all, is this a monomial? Yes, it's all bound by multiplication. Numbers and variables bound by multiplication. So this is a monomial. The degree is the sum of the exponents of the variables. So I got to go to my variables and look at their exponents. I've got 2. Y's got a 1. We don't see it, right? But it's there. We understand y to the first power is y. So we've got 2, 1, and 3. This is degree. 2 plus 1 is 3, plus 3 is 6. So it's not very difficult to find the degree of a monomial. You just add up the exponents of the variable part. If for some reason this was written as 5 squared x squared y 1z cubed, the degree would still be 6. It doesn't matter that the 5 is squared. The definition says you only add the exponents of the variable parts. All right, other things worth noting. The degree of a non-zero constant term is 0. So let's see if we can figure out why. A constant term would just be something like 5. 5 is 5. It doesn't change. It doesn't vary. Why do we call this degree 0? Well, because that's really 5 times x to the 0 power. And as we had learned last chapter, x to the 0 power equals 1. 5 times 1 is 5. So note 5 is really degree 0. By logic we've already learned. A little abstract way of thinking about it, but that's why we say our constants have degrees of 0, because we don't write anything to the 0 power because it's 1, and multiplying a constant by 1 would still be the constant. And for what it's worth, the constant term 0 itself doesn't have a degree. This is one of those things where it's kind of fishy, and 0 is pretty convenient for us, but it's not always clear that it behaves like other numbers. So let's leave that aside for now. All right, here's a chart of things worth knowing, just kind of going through and giving examples of what we've seen. 10 is a number, and we don't see any variable or exponent, so we know it's degree 0, as I just explained. 3x, a number times a variable, is a monomial. The degree is the sum of the exponents of the variables. Well, x, even though it's not shown, x has a variable, an exponent of 1. So we have degree 1. 1/2 AB. Again, they're all bound by multiplication. Note the exponent of A is 1. The exponent of B is 2. So the degree of this monomial is 3. Similarly, negative 1.8 m to the 5th. So we have just 5 for the degree. Pretty straightforward. Things that aren't monomials. If they're bound by addition, not a monomial. If the two terms are, or any, it can be more than 2, if the terms are bound by division, not a monomial. At least, I should say specifically, if the variable is in the denominator. Because we have over here, 1/2 times AB squared is fine, but 2 divided by n is different. You can't have a variable in the denominator. Hard to read what that was supposed to say. This, I think, was 4 to the nth, or 4 to the x, whatever the variable was supposed to be. Hopefully we know that that's an exponential equation or an exponential function after our last unit, but that is not a monomial. Monomials, you can't have the exponent be a variable. It has to be the number times the variable. And x to the negative first. So not a monomial, because variables must have whole number exponents, and we might not. My apologies, I'm going to edit and try to paste this together somehow in iMovie, but I got a phone call and it just made my video shut down. So I don't really remember where I left off. So let's move on. I think we're down here. State if each of the following is a monomial, and if not, explain why not. So 5x squared, definitely a monomial. We've got a constant or a number times a variable, and our exponent is a whole number. That checks the box. It is a monomial. Negative 1/2 times x times y cubed also definitely meets the definition of a monomial. If we want to go farther, the degree would be 4, because we have x to the first, y to the third, so it's a monomial degree 4. This is not a monomial. It is the difference between two monomials. 2 is a monomial and x is a monomial. Together, they are not. They're bound by subtraction, not by multiplication, so they're not monomials. 8x to the third checks the box. Number times a variable to a whole number exponent. E does not. Negative 3 is not a whole number exponent. All right, our whole numbers are 0, 1, 2, 3, 4, going on forever in one direction in the positives. The negatives, once we introduce them, we're talking about another set of numbers called integers. So negative 3 is an integer. It is not a whole number. 4 itself, yeah, a number on its own, definitely a monomial. All right, now we're going to talk about polynomials. So polynomial can be a monomial. This is weird. Mono for one, poly for many. So a polynomial stands for many terms. And essentially, it is either a single monomial or a bunch of monomials being added or subtracted. So polynomial, maybe we want to make a note to ourselves, is monomials being added or subtracted. So if each term in itself, and on its own, is a monomial, and we've got plus or minus signs in between them, we are looking at a polynomial, a many terms. So each monomial is called a term of the polynomial. A polynomial with two terms, binary, two ways, binomial, two terms. So our Latin prefix there letting us know that when we have two terms, we call it a binomial. And if we have three terms, we would call it a trinomial. So example of a binomial, the monomial 5x plus the monomial 2. When we put them together, that is two terms. So this is a two-term polynomial, better known as a binomial. X squared is a monomial, 5x is a monomial, 2 is a monomial. There's three terms here. They're being added or subtracted. So this is a polynomial, and it's called a trinomial. Usually when we get above 3, we don't call them, we don't call them like quadromials or anything like that. We stick with mono for 1, binomial for 2, trinomial for 3, and then we generally just refer to them by polynomials of a certain degree after that. Well, okay, how do we tell the degree of the polynomial? So note, here I have a term that's a monomial degree 2 and a monomial degree 1. The degree of a polynomial is the greatest degree of any of its terms. So this has a degree 2, this has a degree 1, this has a degree 0. The entire polynomial, when they're put together, is degree 2. It's the greatest of all of them. 2 is bigger than 1, it's bigger than 0. So again, how we determine the degree of a polynomial is whatever the highest degree of any of its individual terms is. With polynomials, we like to write them in standard form where our exponents go in decreasing order. So note down here I have x to the third, the next term is x squared, the next term is x, and here we would have x to the 0. If there was an x to the fourth somewhere in here, it would need to go in front. We want our exponents to be in decreasing order. When you write them that way, whatever the term in front of the highest degree is, that the constant, the number in front of it is called the leading coefficient. So we write them in order, something like 5x to the fourth minus 2x to the third plus 3x squared. So x to the fourth, x to the third, x squared. They're in order, making this degree 4. And that's one of the reasons we like to write it in order, is it's very easy to see the highest degree. Highest degree of this term is going to be 4. So it's a 4th degree trinomial with a leading coefficient of 5. So big vocab words for us to get here. Polynomial, many terms. If it has 3 terms, it's a trinomial. If it has 2 terms, it's a binomial. Both are subsets of trinomials. And our degree of a polynomial is the greatest degree of any of the individual terms that make it. The leading coefficient is the numerical value in front of the term that had the highest exponent. All right, so let's try to write one in standard form. If I'm asked to write a polynomial in standard form and identify the degree and the leading coefficient, all I want to do is reorganize this so that the highest exponent is first. Now, highest exponent is x to the third, but note it has a negative sign with it. So we have negative x to the third. There's no x squareds. Then I have 15x plus 3. So I've got every term is accounted for. All of the signs are correct. The 15 was positive, the x third was negative, the 3 was positive. So I've written them in the correct order with the correct signs. And they ask us to identify the degree and leading coefficient. This is degree 3. the greatest of all the degrees of the monomials. And the leading coefficient, we'll just call it LC for our notes, is -1. -1 is the value that when multiplied by x cubed equals -x cubed. So there's kind of like this ghostly -1 hanging out there. At this point, this is one of those things where you should pause this and try this on your own before watching me go through it. Write each polynomial in standard form, identify the degree, and classify each polynomial. There is nothing to be done here. I cannot change I can't rewrite it in any order, but it's degree 4, and its leading coefficient is -3. All right, that wasn't too bad. So this one's out of order. We want to write it in the correct order, which is going to be 5x squared. Note the x term is negative, so it's -x. The 4 term is positive, plus 4. Now it's written in the correct order. This is a trinomial. And it's degree 2. Its leading coefficient is 5. I did not identify this. I should have. This was a monomial. No need to reorder it when it's a monomial. So we identified the type, the degree, the leading coefficient, type, degree, leading coefficient. And again, the degree is the highest exponent. It's pretty straightforward. The leading coefficient is the numerical value being multiplied by that term. So here we have a binomial. There's 2 terms. It is out of order, so I want to rewrite it as y to the 5th plus 8y. That makes it pretty clear that the degree is 1. And the leading coefficient, again, what can I multiply? What is being multiplied by y to the 5th? That still equals y to the 5th. The answer is just 1. Please don't say the leading coefficient is 0, because 0 times y to the 5th would equal 0. 1 times y to the 5th equals y to the 5th. And note there's a big difference there. If the leading coefficient was 0, it can never be 0, by the way, because if the leading coefficient was 0, this term wouldn't exist, and I no longer have a binomial, and I no longer have a degree 5. Sorry, I wrote degree 1 there. I was looking at the leading coefficient. This was degree 5. Okay, moving on. Adding and subtracting polynomials. Some information you guys can read. I'll read it to you quickly. The set of numbers is closed under an operation performed on any 2 numbers of the set that results in the number also being in that set. So basically what this means is if we add a polynomial to a polynomial, we will get an answer that is a polynomial. It's closed. The same is true for subtraction. If I subtract a polynomial from a polynomial, I will get an answer that is a polynomial. So polynomials are closed under addition and subtraction. If you are interested in whether things are closed or not, stay tuned to Algebra 2 when you have to let imaginary numbers into the fold of numbers for algebra to really be closed under all operations. Okay. Adding polynomials in horizontal or vertical format. So adding polynomials is really straightforward. It's just combining like terms. So the vertical format, personally, I never used this, but if I wanted to use the vertical format, I'm going to write that first polynomial. I do suggest we consider the fact that we have the third, the second, the first. If I was missing one of these, I'd probably hold a space for it, and we'll get to see that, I hope, later in the lesson. So there's my first polynomial, and I want to add to it. I'm going to line things up so they match. I want to add 2x squared. That's going to be underneath the 5x squared. X cubed is going to go over here. Note that 2x squared was positive, so we do want to note that. And then I don't have any x terms, but off to the side I have this -1. So this is what I was talking about when I say writing them in order. 0 x's. I can put that in. If I add 0 x's here, it doesn't change anything. It's equal to the same value. So now that they're vertically lined up, I can add straight down. 2x cubed plus x cubed is 3x cubes. Whatever x cubed is, if you have 2 of them and I give you 1 more, you now have 3 of them. Okay, that seems to make sense. Whatever x squared is, if you had -5 and I give you 2, you are now just missing 3 of them. -3x squared. X plus 0x is just x. X plus nothing is x. And -1, technically I've got a plus 0 up there. 0 plus -1 is -1. Adding polynomials was nothing but combining like terms. In the vertical format, you line things up. In the horizontal format, you just go through and combine like terms. So one technique that I'll use is I'll make shapes. Like 3x squared needs to be combined with x squared. 3x squared and x squared, okay, those are both circles. That's 4x squareds. I have 3 of them. There's now one more. I have 4 of them. Let's use triangles for my x terms. Okay, this has a positive x plus 4x. X plus 4x is 5x's. All right, and I need another shape here. Let's use a square. Negative 6 plus 10. So negative 6 plus 10 is plus 4. And that's just another way of doing the addition of polynomials. It doesn't matter whether you like to do it this way or this way. In essence, they are both just combining like terms. So pretty straightforward. You cannot add 3x squared and 4x. They're not common. They don't go together. You can only add things with x squareds to other things with x squareds. Because again, if you have 5 apples and 2 oranges, and you want to put them together, you have 5 apples and 2 oranges. You don't have 7 apples or 7 oranges. It doesn't work that way. So that's what's going on here. X squared, whatever it represents, if I have 3 of them and I have 4 of x, x is something completely different. I can't say I have 7 of anything. I have 3x squareds and 4 x's, but combined they aren't the same thing. Okay, rewrite as addition, then add. So subtracting polynomials. When we say rewrite as addition, what's going on here is the only thing that changes is you have to distribute this negative sign. If you distribute the negative sign, then this problem is now 4n squared plus 5n. Just plus 5. Now, negative 1 times negative 2n is plus 2n squared. Negative times positive 2n is negative 2n. Negative times negative 4 is plus 4. Note, a lot of you still struggle with integers and signs. There's no way around it. You have to master that to be successful at math at the high school level. So be very careful when you're doing math with signs here. This is why when I give you work, I give you the answers so you can check your work. If you don't have the right answer, but you think you understand the process, go back and check and make sure all of your signs are correct. If they're not, great, fix it. If you think they are and you don't understand why you're not getting the right answer, send me an email telling me what you have and showing me your work, and I'll explain, where something might have went wrong. Okay, so now that I have distributed that negative, I can use the vertical method, which means I'm going to line up my terms. I have 4n squared plus 0n plus 5. Right, again, I'm just using a placeholder in that first term, noting that there was no n term. And I'm going to add to that the second term, plus 2n squared minus 2n plus 4. And all of my like terms are grouped. 4n squared plus 2n squared is 6n squared. 0 minus 2n is negative 2n. 0n minus 2n is negative 2n. 5 plus 4 is 9. And that's it. The same thing happens here. The horizontal format, we're just going to distribute that negative sign and rewrite the problem as 4x squared minus 3x plus 5. Distributing the negative sign, this becomes negative 3x squared. Negative times a negative is positive x. Negative times a negative is positive 8. Note, I kept track of that negative sign for each term I multiplied it by. Now we go through and we combine our like terms. 4x squared, negative 3x squared. So 4x squares, and I take 3 away, I'm going to have 1x squared. I don't need to write that 1. Let's see what we have. Negative 3x and positive 1x. So negative 3 plus 1 is going to be negative 2x. And then we have a 5 and an 8, and they can go together. 5 plus 8 is 13. So you guys don't need to use the shape technique. I don't use this when I'm doing math on my own. I use this as a teacher, just trying to show you that the circle shape went with the circle, the triangle and the triangle went together, the square and the square went together. They're like terms. All right, so that is your lesson for the week. You've got a great view of my desk right now. So this week, what you guys are going to have is an assignment on this, and as always, you're going to have the answers, and if you are not getting it, it is your responsibility to ask me for help, because the second half of the week is going to be a quiz, so you want to make sure you understand this stuff before you get to the quiz. I hope you are doing well. Take care. Bye.